So let's discuss this first question. The moment of inertia of a hollow cylinder of mass m and radius is r about its axis of rotation is mr square. So we all are familiar with it, right? That the moment of inertia of a cylinder, hollow cylinder, about its axis is mr. So the radius of gyration of the cylinder about this axis is what? No issue. We know that the relationship between radius of gyration and moment of inertia is given by mk square. And here the moment of inertia is already given, which is mr square. You can equate these two equations. You'll end up with k is equal to r. Very easy question. Now let's solve this 13th question. The question says that if no external torque acts on the system, then total angular momentum of the system remains constant. Okay, conserved. All right. Now 14th question. The velocity of the center of mass of a solid sphere. So the center of mass of a solid sphere is its midpoint, right? And it is having a radius of r, rotating with angular velocity omega. All right. Passing through its center of mass. Question is the velocity of the center of mass of a solid sphere will be what? This is the question. So here it is only rotating. There is no translation motion, right? And we can also, so the axis is passing through this point. Yes or no? This central point. Yes. And they are asking us to find out the velocity of this point, which is at the center. That is the center of mass of a solid sphere. So if the axis passes through a particular point, let's say point P, okay, then the angular velocity will be zero for this point, right? Because here the axis is passing through it, so there will be no velocity, linear velocity, because axis is passing through this point P. The velocity is zero. So can you explain why it is zero again? V is given by r omega. There is no distance r, right? Here distance is zero. So velocity is zero. Okay. Question number 15. The radius of a gyration of a uniform rod of length L about an axis passing through its center of mass and perpendicular to its length. So it is very easy. This is the L length rod. Axis passing through its center of mass. Center of mass of this rod is at the middle. We know that the moment of inertia about the midpoint for the rod is given by ml square by 12. And they are asking us to find out the radius of gyration. And we know that the relationship between radius of gyration is mk square. So from here, k square is L square divided by 12. So k is L by under root 12. This is the answer. Question number 16. In the given figure below, bullet of mass m moving with speed u strikes a rod AB of mass capital M. Here the mass of this rod is capital M, and bullet was having mass small m, and it was moving with velocity u. Gets embedded into it. That means it sticks sticks to the road, right? This bullet. Yes or no? So now new mass of this road would be m plus small m. Okay. If initially the road is vertical and hinged at point A, then angular speed of the system just after the collision will be just after the collision, angular speed of this system would be what? That's the question. So remember, conservation of angular momentum. We have not discussed it yet, but we will discuss it. Okay, it is similar to conservation of what?
Angular velocity.
It is similar to conservation of linear momentum.
Momentum.
So first of all, this is the relation between moment of inertia and omega. Okay. According to angular momentum conservation, initial angular momentum must be equal to final angular momentum. So that means I1 omega 1 must be equal to I2 omega 2. So let's call it omega 2. Okay. So initially when this bullet strikes this rod, it is at distance L, right? And it is having a linear velocity of u, as you can see. So here the angular momentum is r cross p, right? Here r is L and p is mv, so m multiplied by u. So it is mul. This was the initial angular momentum. Okay. Again, read the question. The road is vertical and hinged and then angular speed of the system just after the collision will be. We need to find this omega 2. It will be I1 omega 1 divided by I2. So we just need to worry about this omega 1 moment of inertia and I2. Okay. We got this our initial angular momentum, which is mul. Okay. So this was the linear, this was the, this is the same thing. Okay. Here we can use this mul, or we cannot. What do you think? Can we use this thing or not?
Yes, so we can use this. But in this question, when we after mul and is equal to I2 omega 2, so then how do we move forward with this?
It will be mul plus I omega. Okay. But here the initial momentum was 0. Sorry, angular velocity was 0. So we don't need to worry about this. So mul, here this is small m, u, l is equal to I2 omega 2. Now what is I2? So it is rotating about this point. So here I2 is ml square by 3 plus small m l square, right? Capital M
Why
L
ml
square
square?
by 3 plus small ml square omega 2. Huh? What?
ml square, why is it that?
Array I2. The next moment of inertia would be what? So for this rod is rotating about this point, right? At hinged point. The moment of inertia about this point is ml square by 3 for the rod, right? And we
Yes.
need to add this bullet's moment of inertia also. That will be small ml square. That is what we did here.
Okay, okay.
So from here omega 2 is mul divided by capital ml square plus small ml, right? So we
Yes.
can cancel out these l's. We'll end up with if you take 3 as 3 as LCM, then it will be 3ml plus capital M L, right? It will be 3mu divided by, you can take L common, so it will be 3m plus capital M. Okay, so this is the answer. Understood?
Yes, sir.
This was a real good question. Now let's go for this 17th one. Rigid body rotates about a fixed axis with variable angular speed omega is equal to 3 minus 5t at any time t. The angle through which it rotates before it comes to rest is what? So it's a really easy question. Okay, so I'm giving you this question in homework. Okay, you can take a screenshot of it.
Yeah,
It's
okay.
like this question is similar to a car which is going with some velocity, linear velocity, and suddenly this man applies the brake. So finally the car comes to rest, right? So the final speed would be zero. So here you need to find out the acceleration and things. So it is similar to this question, this scenario, okay, but
Hmm.
in a rotational manner, okay. This question number 18 is really good and very important. Many times JE and NEET exams ask these questions, okay. Oh, sorry. So if suddenly Earth radius reduces to 1 upon n times, so this is our Earth and it is rotating about its axis, okay. So here radius is becoming 1 by n times, right, to its initial value, while its mass remains the same, okay, mass remains the same. New duration of the day becomes what? That is what requires here. So what concept we can apply here? Obviously, conservation of angular momentum, okay, because no other forces are acting on this body. Yes or no?
Yes, but I did not understand what the question meant. Initial value while its mass remains same. New duration of 1 day. What is it?
Right now, the duration of the day is 24 hours, right?
Yeah.
But if you reduce the radius of the Earth, it will not remain same. It will change. So that is what
Hmm.
they are asking us to find out. Understood?
Okay. Yes, sir.
So
Understood.
we are conserving the angular momentum by applying Li is equal to Lf. That means I1 omega 1 is equal to I2 omega 2. Okay. So initially the, let's say, moment of inertia was I, and angular velocity was omega 1. The final is I2 and angular velocity is omega 2. Okay. Now considering this Earth as a sphere, The moment of inertia of a sphere is given by 2 by 5 mr square, right? It is 2 by 5 mr square. And we can write this angular velocity as 2 pi upon t. Yes or no?
Yes, sir.
Here the new moment of inertia would be 2 by 5 m r dash square multiplied by 2 pi over t dash. Just cancel out whatever you can cancel out. Okay? You can cancel out these masses, this 2 pi. So we'll end up with only r square by t is equal to r dash square divided by t dash. So basically t dash would be what? R dash square multiplied by t divided by r. Now they clearly told us that new radius r dash becomes 1 by n times of initial one, right? So we can use
Yeah.
this here. So it will become r square divided by n square r square multiplied by t. We can cancel out these r square. So we'll end up with t by n. And what's the current time period? It is 24 hours, right?
Hmm.
This is the answer, 24 by n. Understood? Very good question.
Yes, sir.
So I'll come up with more questions, alright? Right now, that's it for this, session.